Hello, everybody. Thank you for joining us today. I'll give everybody a moment to come in. We'll get started with the past community news, and then we will turn this over to A10 for the HADR session. Okay, so first of all, thank you all for joining us with this month's installment of the past HADR virtual chapter. So if you're watching this live, good morning, good afternoon, good evening from wherever you're from, or if you're watching this on the recording, thank you for taking time out of your day. So let's get started with a little bit of news, and then we will turn this over. Okay, first of all, if you have not already signed up for the PASS Summit this year, please. It is, in my opinion, the best SQL Server and data platform specific conference that you can get. It is virtual this year due to COVID, but that's okay. The content is going to be awesome. We're all going to be there hanging out. It's going to be a really good time, and the content is amazing. So go check it out. Register today. The price has been reduced from what it is in person, and this means you can join from the comfort of your own home. So the first week in November, go check it out. We are not the only virtual chapter out there. If you've not subscribed to a number of these, you need to go do this. It's phenomenal information. You don't have to watch them live. All these are recorded. They're all posted on the past YouTube channel. So go sign up when you can. There's phenomenal content out there. And as anything with our industry, you have to be constantly learning. So go check these out. If you're interested in a new career, or if something's happened this year and you're looking for a good job, or if you're recruiting, if you're recruiting, go check out the PASS Career Center. It's a phenomenal place with people of our like-minded industry to go look and see what's out there. So go check it out. Connect with PASS, all the usual social media channels. It's well worth your time to go do this, especially with the way this year is going. This technology community that we're in is truly something special. So the networking, the connections you're going to make, the education you're going to receive, it's all fantastic. So go check it out. And with that, I'm going to turn this over to, let's see, to A10. So this is how to HADR your SQL Server jobs. So I'm going to make you the panelist. And let me know when you can. There we go.
Is my screen being shared?
It is.
Okay, nice.
Perfect. So if anybody has any questions, you're welcome. If anybody has any questions, please put them in the chat window or the questions window, and we will answer them as they come. We've got some breakpoints in the session for the session. So there you go.
Cool, thank you. Okay, so how to HADR your jobs or header your jobs. A few words about me. So my name is Ethan Blooming, or you can also call me Ethan Blooming, whatever it is. I've been a SQL Server consultant since 2010. Been working with SQL Server since 2005. I'm currently working as a senior SQL Server consultant, solutions architect, and DBA team leader at Madeira Data Solutions in Israel. I'm recently became a data platform MVP just this past month, so congratulations to me. I'm also co-hosting the SQL Server Radio podcast together with Guy Lancer, also from Madeira Data Solutions. So go ahead and check that out if you haven't yet. What this presentation is about. So we are here to solve a particular use case of where we have, let's say, 2 or more SQL Server instances with some kind of high availability disaster recovery solution set up between them with availability groups or database mirroring. So we have the database level synchronization taken care of and the failover by that solution, but we don't have a similar solution for SQL Server scheduled jobs. And whenever the SQL Server instance or the database rather fails over for whatever reason, there is no built-in mechanisms for the jobs to take that into consideration automatically, as in which jobs should run only on the primary instance, the primary replica or the principal, and which jobs should not. So we end up with all kinds of problematic scenarios And we'll see how to tackle that and what's the best practice, what's the best way to solve that. So what I often see with real world scenarios, real world systems, is that customers usually, organizations rather, usually don't actually implement any sort of solution. The vast majority of environments that I see, they just let the jobs run or not run wherever. If the HADR solution fails over, and then the jobs may stop working because the database in question is not available, it's not writable, not readable. And I'm going to put aside for a second the fact that actually the situation out there is even worse than that, because I often see scenarios where there is so much difference between the primary and secondary environments, where jobs that exist on one server don't exist on the other server, or maybe there is some kind of difference. So that's an issue in and of itself, and I'll talk about that a bit towards the end. But currently what I want to look into is how to solve the issue of due to failover, as in the jobs need to work, let's say, only on the primary server, and they cannot work on the secondary, they're going to fail. So what are the problems with this? Well, first of all, this is going to, if we have some kind of monitoring platform in place that tells us, notifies us, alerts us about failed jobs, obviously this is going to cause a lot of noise. And we don't really need these alerts, because these jobs, they don't fail because there's some kind of inherent problem, but rather because they actually need to run on the other replica, other server. So this causes false alerts if we have some kind of monitoring. It also fills up the MSDB job history tables, and that causes other kinds of problems. For example, in terms of retention, history retention of jobs. I don't really need to see the history of a job where all I see are just failures, because it wasn't running on the correct instance. It's not interesting to me as a DBA. I want to see, if I want to see failures, I want to see them because there was an actual failure, right? So it causes noise also for the database administrator that wants to troubleshoot failing jobs. One common solution that I see is where they take each job and they add a preliminary step, like a first step, that all it does is check whether the current database is the primary or not. And if it's not the primary, then raise an error with some kind of high severity, let's say 16, which causes the step to fail. But in the settings of the step, we tell it to, in case of failure, complete the job with success. So even though the first step fails because the database is not accessible because it's not a primary, the jobs are still completing successfully. So we get rid of the, let's say, it solved the noise issue caused by possibly automated alerting platforms. But, okay, yeah, so that's how it looks like. So we have like a preliminary step, and it is set as the start step, the starting step. And if it succeeds, as in the database is indeed the primary, then it moves on to the next step, which actually does the real work. But the first step is still failing. So if you look at the job history, we see this kind of mess where there's like these warning signs, and when we open them up, then we see actual failures at the step level, but even though the job itself is completing successfully. So this also poses a problem for a DBA when they want to troubleshoot and look into the execution history of jobs, because this is a lot of mess. This is lots of noise and not interesting stuff that it also takes up valuable space in MSDB, in the job history tables, and it makes it difficult for me to troubleshoot job history execution history, sorry. So the way I see it, this is the best solution that I know of. So the idea is as follows. There will be one additional job, which we would call master control job. What it would do is that it would automatically either enable or disable all the jobs based on the role of the relevant database, whether it's primary or secondary. So let's say these jobs, every time it is executed, it checks if the database in question or databases in question are primary, then the jobs should be enabled. So let's check the status. If they're not enabled, so enable them. If it's the secondary, then they should be disabled. So do the same thing, or only in reverse. So the logic of this job would be something like this. As I said, if current server, for example, is the primary, then enable all jobs. Otherwise, disable all jobs. But there's a question here. What does it mean when the current server is primary? I mean, is it the SQL Server instance? What does that mean? Because the availability group is not at the instance level, actually. It's per one or more database. The same thing goes for database mirroring. Mirroring is configured at the database level, but jobs are at the server level. So that's a bit confusing. So which do we check? Do we check the instance, whatever that means? Do we check a certain availability group? Do we check a certain mirroring session? It's a bit confusing, certain database. So what we would decide at this point is that let's assume that we know which database to check. We have some kind of database that we want to check. We want to see, regardless of whether it is part of an availability group solution or a database mirroring solution, we know which, let's assume that we know which database to check. Okay, so we check whether it's the primary. If it's primary, let's enable all jobs. Wait a second. Do we want to enable all jobs? Are all jobs actually relevant to this database? This is not so clear cut. Maybe we need to enable a list of specific jobs, like let's predefine them somehow. Maybe, I don't know, based on category or some kind of name or part of a name. Or maybe we can do this check based on the database context of the steps, the T-SQL steps within these jobs. This data is actually available to us in MSDB. We can check for the steps of each job, what is the database context, and then check based on that. Cool, okay. So let's assume that we know which database to check. Let's assume that we know which jobs are relevant. Wait a second. Do we need to enable all the jobs specifically when the database role is primary? What about jobs that need to run only on the secondary replica? Let's assume for a second that we are talking about availability groups with readable secondary, and we have some kind of let's say data warehouse sort of process that needs to only read data from this database. So maybe we actually want it to run only when that database is secondary, so that we would not cause too much stress on the primary replica, because there will be also reads and writes there, so there will be additional stress. There's all kinds of decision making here. Maybe I have jobs that need to run both on both replicas, even when the database is primary, and also when it's secondary. Maybe it's some kind of monitoring job, or I know there's all kinds of possible use cases. What if a job is never supposed to run? I don't want it to be re-enabled again whenever there is some kind of change, or whenever the master control job is being executed, right? Maybe for whatever reason, I decided that a certain job needs to stay disabled. Maybe I created it some time ago, and I want to disable it now, or maybe just to temporarily disable it without having to delete it. It's a possible use case. Okay, so let's make it a bit more complicated. Let's say that our algorithm would check for whether the job or step or category name is something, let's say it equals to something, or is like something, it contains some kind of string, starts with a string, whatever it is. Then we check for the database role relevant to that job or step or category of jobs. And let's say if it is primary or secondary, or either, or none, or actually none doesn't make sense here, then enable, otherwise disable. And this sort of algorithm would be repeatable per, let's say, a list of jobs and steps and categories and databases. And let's say, like, we would construct a list of rules which would control which jobs would be enabled or disabled in which use cases. So I think that looks like a good solution. So we'll go with that. But now the question remains, when should we schedule the master control job to run? Because now we are seeing the same issue here that we saw previously on the regular jobs, because this master control job needs to run, I suppose, quite often. If I have some kind of job that runs, let's say, every 10 minutes, and I want this master control job to be able to either disable or enable that job before it is executed, like let's say incorrectly, okay, on the wrong replica. So I want to be able to set its enable or disable status at the proper time. So I would have to run this master control job often enough so that I wouldn't miss executions of other actual jobs. So that's going to be a problem, because first of all, that depends on which jobs you have defined on your server, which is something that can change over time. And second of all, this also fills up your MSDB history, your job history. And I would reckon that the vast majority of these executions actually are not doing anything, because how often does it happen that you have a failover? It's not too often, I suppose. I hope for you, okay? So the vast majority of executions wouldn't actually change anything. We don't actually need them. So this takes up, it uselessly takes up space in MSDB, and we would rather avoid that. There is a solution for that called alerts. So in SQL Server agent, we have a mechanism called alerts, which is an event-based mechanism that we can use to execute jobs. So whenever an event is triggered of some kind of type, and that type could be a role change for an availability group or a state change for database mirroring, then we would run the master control job. I see there's a question.
Yes, how frequently would you run this master control job?
Okay, so I think I just answered that.
Yep, I think so.
But yeah, but based on the previous slide, basically the idea is at least as often as your most often job, other job that is being executed the most often. But as I said, this poses other issues such as bloating up the history of MSDB and making it difficult for the DBA to troubleshoot and investigate the execution history of this master control job. So the alerts in SQL Server are a good solution for that. Oh, and also it's important to note that these jobs, these master control job, should also run on SQL Server startup, because let's say we had some kind of hard failover, one of our servers was turned off all of a sudden, hard shutdown, and so now it is being started. It starts again, and we would want the first thing that the SQL Server would do is first of all check what should be the status of its jobs. Should they be enabled or disabled? So we would do that by adding a schedule, which is triggered by whenever the SQL Server agent starts. And also, just in case, it would be beneficial to have some kind of schedule. Let's say not necessarily as often as other jobs, but let's say once per hour, or once per half an hour, or once per 2 hours. I mean, something minimal, you know. It doesn't have to be too often, because it would hope that hopefully the alerts will take care of that on demand, event-based. But we would also, just in case, every so often, you know, just to make sure, check the status of the HADR solution and make sure the jobs are at what they should be. Okay, so that sounds like a plan, right? Looks like we have a working solution. We can start doing that. But does that mean we need to implement this now? That sounds like a lot of work. I mean, we went over like quite a complicated algorithm that we need to implement here. Is this why I brought you here, to tell you go ahead and start working? No need to do that. I actually already done all the work for you and prepared this as an open source solution. So you can see on screen the link to our GitHub. This solution is available for free. There is a variation of it for AlwaysOn availability groups, and a variation of it for database mirroring. Now let's take a look into how it works. So the way it works is that there's all kind of algorithms and complex queries that happen as part of that master control job that the solution is creating. But at the top of the job, we have these parameters, let's call it that. Okay, so we have the master control job name, which is how we would want to call it. These are the default values. Same thing for the corresponding alert name. How should we name the alert that would trigger this job? Next, we have the special configurations. Now, as you can see, this is XML. And when I first started developing it, I had a conundrum, like how would I implement the flexibility that I need? I was thinking about several possible implementations. I thought about using like a set of parameters that would work in tandem, or maybe table like maybe table variables, maybe create a table with configurations. But I decided that all of these solutions, first of all, they will be difficult to maintain, especially when you have lots of moving parts. You know, like when you have many different separate parameters, or when you have now a separate object like a table that you need to maintain and create and like save it in some database as an object. And I don't think that's actually necessary. I think the best solution is a single variable which can hold a set of data, such as an XML. JSON was also an option, but there was an issue with it because it would not be backward compatible with SQL Server versions older than 2016. But XML works all the way back to 2008. So I decided, due to backward compatibility reasons, XML is the best choice, even though it's less efficient possibly than JSON. Okay, yeah, talked about that. So you don't actually have to configure these special configuration parameters. It is actually optional because it has a default behavior. The default behavior is this. Let's say we take as an example, we have one job. Okay, it's called my job 1. It has 3 steps. Each step is executed within the context of a different database, AdventureWorks, Pubs, and Notwind, for example. So the default behavior says that if at least one database, wait a second, I'm going to hide it. Okay, if at least one database, one step in that job should be online, then we enable the whole job. And if there are, for whatever reason, which I hope is irrelevant to you, but if for whatever reason you end up with a situation where you have one step running on AdventureWorks, which is primary and online, but Notwind is secondary for whatever reason, then it will be up to you to implement the necessary precautions. For example, add an if statement inside the step that will make sure that the database is indeed online and accessible and with the correct role. But hopefully you don't have this complex type of scenario. Okay, so let's go over these examples that I have here and understand how these configurations work. So we have the config, which is the root element. Inside is all the rest, all the items. So each item element represents a rule, let's call it that, okay? So we have a type attribute, which tells the master control job, what am I checking? What am I looking for? Am I looking for a job? Am I looking for a category or a step? And so that I would know which jobs should be affected by this rule, okay? And then I have another attribute called enable when, so that I would know when should this job or jobs should be enabled, when the role of the database, the relevant database, is what. So for this example, what this says is that for all jobs that start with Contoso, and there's something, as you can see, there's like wildcard here, which is used in a like expression. So all jobs whose name starts with Contoso, we enable them whenever at least one step belongs to a database which is currently the secondary role, as the secondary role. This rule, for example, says that all jobs within the category called database maintenance should be enabled in both cases, regardless of whether the database context is primary or secondary. It should always be enabled. This, for example, should work very well with Ola Hallengren solutions, because his jobs already take into consideration the status of the relevant databases. Okay, so this is similar to the first rule. Oh, no, sorry, this is the step. Yeah, right, okay. So the type here is step, which means all job steps that are called generate BI report, they should be enabled when the relevant database has the secondary role. This is a rule at the step level, so this affects the whole job. And if this affects at least one step of of the job, then the whole job is enabled, if you recall. Now this is a bit more interesting. Now we have a rule of type category called SQL-centric jobs. So all jobs that belong to category SQL-centric jobs enable when ignore. This is not secondary and not primary and not both. This is ignore, so which means do not touch the enable or disable flag. Don't change these jobs, because maybe some of them should be enabled, maybe some of them should be disabled. Whatever it is, it doesn't matter. You need to ignore them. For example, SQL Sentry by default creates two jobs. One is enabled and one is disabled. So this is like the default behavior of SQL Sentry. We wouldn't want to change that. Now here, for example, we have a type job called WWI, Wide World Importers, ETL, which should be enabled when the database called WWILT has the primary role. Now, enable when primary is actually the default behavior. Okay, so if you have jobs that don't fall into these categories, these rules. No, sorry, when you don't have this configuration variable parameter, when it's null, the default behavior is check all jobs whose database context is involved in some kind of availability group solution, and enable it when that database is primary. That is the default behavior. So this will be a bit odd to add here. What it does is takes care of an edge case, where basically I don't actually have a database context for a job step. For example, SQL Server Integration Services, SSIS. There is no database context there. It's not T-SQL. It executes some kind of external process, which is the SSIS package. But it could depend on some kind of database, and I would still want to control it based on that logic. So I can force it to check a specific database name instead of the database context of the relevant steps. So you can either use it for use cases when you don't have a database context, such as SSIS, or maybe you have CMD exec steps or PowerShell steps and so on, or when you want to override it for whatever reason. You get this flexibility, whether you need it or not, that's up to you. But just so you know that you have this flexibility available to you. Okay, so also you have enable when never, which is basically a way to tell the algorithm to always disable these jobs, make sure they are always disabled. In this case, I want all jobs in the disabled jobs category to always be disabled. I can either, maybe I have a set of jobs that I want to have to be disabled, so that this could be an example of how to enforce that, either with enable when never, or enable when ignore could also work. Okay, so I think that's actually about it. How are we with time? We have enough time for questions.
Yeah.
So I'm guessing that probably people will have questions regarding this algorithm. So this is a good time to ask those questions.
Yeah, if you have any questions.
I have a few, sorry to interrupt. I have a few more things to go over after this. So let's pause here for questions, and then we will move on.
Okay, if anybody has any questions, please put them in the chat window right now. We don't have anything extra. This is fantastic. I can't wait until I can start tinkering with this.
Yeah, it's a wonder that Microsoft don't have something like that already built in, because I would figure this is a must. Whenever you have some kind of availability group or database mirroring, I would consider this a must.
So if there's somebody from Microsoft listening, I'm sure you can work some sort of license agreement with them.
Interesting.
There are ways. There are ways to do this.
Yeah. Okay. You know where to find me.
Yeah, exactly. Okay, I'll let you go ahead.
So
There
I still have no questions at this point.
Yeah.
So let's move on. I have a few more. Okay, so I touched at the beginning about the issue of there being a difference between two replicas, like when two replicas have different jobs. We have missing jobs. We have jobs that are maybe the same name, but they are different. Maybe the administrator updated the job on one replica, forgot to update it on the other replica. Possible scenario. So this is based. I developed this due to an actual use case at the customer. So this is also an open source solution that I developed. This is a PowerShell commandlet. Let me open it up for a second. Okay. Do I have the list of parameters here? Yeah, okay, there it is. So this is a commandlet in PowerShell, which basically it is meant for comparing between the jobs of a availability group replicas. So I gave it a computer name, which is an entry point. This is one SQL Server instance name. That what it does, it connects to this server and then automatically detects what availability groups exist in this server, which databases are contained within these availability groups, and then which jobs are connected to these databases. And then it takes these jobs, it compares these jobs against the same the same idea. It takes the same idea for each replica. It gets the jobs list that is relevant to the availability group per each replica and compares the list of jobs. There's a command in PowerShell that is used for comparing objects, so that was very useful. So I simply compare a list of job objects. Okay. And whatever difference that it finds, it outputs in an HTML format like this. So we have like a table of jobs, which one is the master server, which one is the target server. For now, by default, the master server is whichever server is the primary, okay? And the target is the secondary. Either way, so it has like this indicator that shows you, for example, this one means that this job exists on both servers, but it is different. Maybe the description is different, maybe the steps are different, maybe the schedule is different, or whatever, any one of those settings. If we have this kind of icon, means that the job exists on the target, but not on the master. And if we have this kind of icon, then it's the other way around. The job exists on the master replica, but not on the target replica. So I take this list of differences and I generate a change script. So that change script is already generated as part of this solution. And I have the option to send it by email. So this thing is sent optionally, can be sent by email with the change scripts in plural also attached to the email. And this report can be generated per each availability group. And the change script is generated per availability group. Okay, you could have multiple availability groups on your servers. So this check is performed separately per each, and you get all of them together in the same email. Or you can simply tell the script the output folder, and then it saves into the output folder the HTML file, which is the difference report, and the change scripts. So these solutions, in terms of flexibility, as you can probably see, it's less flexible than the master control job, because it doesn't have that special configurations parameter. It only has this default behavior for checking the list of relevant databases, finding the list of relevant jobs based on the database context, and it only compares those. I did not, it was too much work basically in PowerShell to implement anything beyond that. So this is, as you can see, as I already said, this is also open source, available for free. You can use that for your own leisure. And also I implemented this only for availability groups, but the same idea could theoretically work with database mirroring. I did not implement it yet, but it should be simple enough to do. I probably would implement it sometime in the future. Okay, so this is documentation for all the parameters and explanations. You can find it here. Okay. One more thing that I want to talk about is DBA tools. Speaking of PowerShell, I cannot talk about PowerShell without also mentioning DBA tools. DBA tools is an awesome set of PowerShell commandlets for SQL Server database administrators. And the most useful command in this case is called sync DBA availability group, which what it does is contact the server for information. For too long, okay, yeah, okay. So what it does is synchronize for you all of these different objects that you can see on the screen, and the instance configuration, custom errors, credentials, database mails, login permissions, agent categories, operators, alerts, proxy schedules, and jobs. So this is like a monster commandlet that can do all of this for you and synchronize between the replicas of an availability group. This is very important because what we end up seeing is that jobs could sometimes be the least of your worries. When you have an high availability disaster recovery solution in place with a failover, you should have identical environments in both of your replicas, which means same jobs, but also the same logins, the same schedule, the same operators, the same server triggers, maybe same linked servers, and so on and so forth. Because if your system, your product, your software, your databases work a certain way on one replica, they should work the same way exactly on the secondary replica as well in the event of a failover. Too often we encounter scenarios where organizations are like, they don't really care. I mean, they consider a failover event to be like something temporary. Like, yeah, okay, maybe it will fail over, and then some things would not work as expected, but we would want this to be like we would expect it to be temporary. In reality, you can never know. You would never know how long it would take before you can fail over back to your original primary. You'll never know what you could affect during this time window, and you will never know what could fail. So it is actually important to make sure that you have identical environments. And actually, this point is relevant not only to SQL Server objects and configurations and so on, but also to everything around it, which could be, for example, file and folder permissions. What's it called? UNC path that should be accessible to both replicas if you have processes in your SQL Server that access files or folders over the network, and you want to make sure that both replicas can have the same access to these files and folders or URLs or whatever it is. So basically the whole environment, the whole set of services and folders and permissions and accounts, you should have an identical environment in both replicas across like the whole spectrum, okay? So DBA Tools has a huge list of commandlets, not just in DBA Availability Group. You can also have all of these copy commandlets where you can copy certain types of commands. So that also can be very useful. You can use that to make your job a lot easier. And that's actually it. So now, again, I'm going to ask for questions. And if there is anything, you can go ahead and write them in the chat.
Sweet, that was fantastic. There's one question here. Will the schedule UID show in the job comparison?
You mean in this one, the one I wrote?
I believe so, yeah.
No, I think not. I think I explicitly ignored that.
Okay.
I also ignored the job ID, I think. And you know, all of those internal values that could be like identifiers. There were all kinds of fields that I noticed while I was developing this. I noticed that were all kinds of fields that were problematic. Oh, also like a create date, update date of a job. I don't actually care about that, so it's not something that I should be comparing.
Okay, that's a good question.
So yeah, I made a point for myself to only compare what actually needs to be compared. Yeah.
Okay, so there's a good question on here. Not knowing XML, what is the expected learning curve before implementing that solution?
I think it's very low. I mean, I would figure that this thing is kind of self-explanatory. I mean, it should. I really try to make it as simple and straightforward as possible, with minimal, so that you wouldn't have to mess around too much with XML. So this is very like almost spoken language. You know, I have the config, I have the items inside. What type of item? When do I want to enable this item, the jobs that are relevant to this item, and so on. So I really tried to make it as simple and easy as possible for usage.
It does seem very straightforward. I would say for the gentleman that asked the question, would he be able to reach out to you on social media if he has any questions?
Of course.
Sweet.
Yeah.
Very cool. Yeah, can you show your contact information at the end there?
Let's see. Did I put it in? No. Okay. So let's start from the start. Hold on a second. Yeah. There
we go. Perfect. So yeah, for anybody out there, if you have any questions with the solution, please reach out to him, ping me if you need any questions with it. It's one of those, we're a happy community. We love to do this stuff, and yeah, we're happy to help because this is one of those things. No exaggeration. I'm probably going to be downloading this afternoon and tinkering with it.
I'm happy to hear that. Thank you.
Yeah, this is
Yeah, and
great. I've tried to.
as you probably noticed, the solution is on GitHub. So you can also feel free to open issues on GitHub if you have feature requests or bugs that you find. So that's also an option. Yeah.
Perfect. Yeah, no, I think that is all the questions that we have. If there's any other questions, we have a few more moments, so go ahead and drop them in the chat window here. Otherwise, I'm not kidding. I've rolled my own version of this in the past, but it's not as elegant as yours. And
Thank you.
I honestly feel like I'm going to take some time this afternoon. I'm going to download it myself and tinker with this because I've actually got 2 sites right now that I could really use this at.
Cool. That's very cool.
It's,
So this is already working in production. I have this in several sites, and it's working very well.
perfect. Yeah, I'm going to have some fun putting it in some pretty big sites.
Cool.
Awesome. So yeah, okay. So if there are no more questions, I think we'll go ahead and break for today. This will be recorded and put out on YouTube, hopefully later on today. Thank you, Eitan, for speaking today. We really appreciate it. And quite honestly, if you'd like to do another session in the future, let me know. We'd be happy to have you back.
Thank you. Thank you. I will. Thank you for
Awesome.
having me.
You're welcome. Thank you, everybody, for attending. And we look forward to the next one next month. Thanks, everybody.
Bye-bye.
Bye now.